Thanks everyone for showing up again. This is Dan Broussard. We're going to get started in about 2 minutes. I want to thank everybody for joining us with Thales today for Lunch and Learn. And we'll give everyone about 2 more minutes. We're up to about 40 attendees. We're expecting a couple more. And then we'll get started here at 5 after half hour. So give me 2 more minutes and we'll kick it off. Thanks again. All right, we're going to go ahead and get started. We're right at 11:35. Again, my name is Dan Broussard. I'm with Set Solutions. I'm the EVP of Sales. Thanks everyone for showing up today to learn a little bit about bring your own key for cloud infrastructure specifically. What we see today in the marketplace is a lot of our customers are moving to cloud. So that's either through IaaS or SaaS or PaaS. And part of what their main concern is, now my data is not in my data center, and I want to be able to control that data. What better way to control the data than to encrypt it with a key that only you have? And we'll go through how that works today. But I want to kick it off and introduce you to Eric with Thales. And we appreciate everything. One just housekeeping thing I want to cover off on is we are going to do a survey of all the attendees after this. We will randomly pick a winner, and that winner will win an Amazon gift card. So when you see the survey go out, please give us some feedback, some good feedback on if this was a good session for you, what you liked and didn't like, and what we can improve on. So thank you very much, and I'll turn it over to Eric with Thales. Good morning, Eric.
Good morning, Dan, and thank you very much. As you can see from the title slide, I'll be sharing today's presentation with my friend Victor Mendoza, who is a senior security consultant at Set Solutions, who has produced a fabulous series of videos that will show you where they are and how to find them. And the structure of today's discussion is that I'm going to explain to you why to bring your own keys to the cloud. And then Victor is going to explain how to bring your own keys to the cloud. So let's just dive in. The statistics that you're about to see come from several studies that Thales has performed with analyst firms over the past 9 months or so. And this statistic comes from the 2019 Thales Cloud Security Report. And I title this statistic Glass Half Full or Glass Half Empty, because the first time I presented this slide with my friend Larry Poneman, Larry stated that businesses are not applying adequate security measures to protect sensitive data in the cloud, because the cloud security study results said that only 49% of organizations were encrypting data there. Well, I feel that's a glass half full or glass half empty story. Why? Because I've been presenting statistics like this for 4 years. I joined Vormetric back in 2016. And when I presented this statistic in late 2016, the number was 22%. So from a glass half empty, glass half full perspective, we have seen stupendous growth in the penetration of encryption to protect data in the cloud. And I think that's a good thing. That said, it means that half of our data is unprotected by encryption in the cloud, and that's a story worth considering. Now, why data is or isn't encrypted in the cloud is partially explained by this finding from the cloud security study last year, where we asked, well, who do you think is responsible for protecting sensitive data stored in the cloud? And the peculiarity that we saw here was that the respondents felt that there was differing responsibility. Sadly and frighteningly, 35% of the respondents thought that the cloud provider was entirely responsible for protecting sensitive data in the cloud. And unfortunately, that is flat wrong. We're going to talk about that in a moment. And mercifully, a large majority in total, 64% of users felt that it was either their responsibility or shared with the cloud provider, which is the correct answer. And so the reason why this is crucial has to do with encryption and what's going on with protecting data in the cloud, which I will get to in a moment. Now, we asked what users who were encrypting data, what they did with their keys. And what we learned in the cloud security study was that a little bit more than half of cloud users are controlling their encryption keys one way or another when data is encrypted in the cloud, while a large majority of them, 78%, says that it's important to retain ownership of the encryption keys. So when I present this slide, I think back to Victor's presentations, Victor's videos that we'll give you links to in a short time, because Victor tells the story of cloud key control from the very beginning of the story. And it is one of the best ways to understand the statistics that you're seeing here on this slide, because depending on what you do about encryption keys, you don't really have to control them if you don't want to. You can leave them entirely in control of the cloud provider. You can also entirely control them without even bringing them to the cloud. You can use cloud provider originated keys and control them. And Victor's videos explain this really, really well. And I'm strongly going to encourage you to take a look at them, but back to the why. Before I move forward into more whys about BYOK, I'd like to take a short time out to talk about multi-cloud. Larry Ponemon took the statistics and stated that businesses adopt a multi-cloud strategy when they need to. And this statistic was interesting because in the cloud security study, only 48% of organizations explicitly stated that they have a multi-cloud strategy, with AWS, Azure, and IBM being the top three cited cloud providers. The reason why this is particularly interesting is that in different studies, and depending on how you ask the question, you discover that while organizations might not have a multi-cloud strategy, they are actually consumers tactically of multiple clouds. Because in the Thales data threat report in early 2020, we revealed that I think 92% of organizations, one way or another, are using multiple clouds. And there's no surprise there because customers tend to use a very, very large number of SaaS applications at least, but we also find that customer consumption of cloud, infrastructure as a service, and platform as a service just simply turns out to be multi-cloud, because organizations tend to choose cloud providers based on specific technologies available in infrastructure and platform as a service. But there is, in fact, a shared responsibility model for cloud data security, which is depicted in this highly simplified illustration of the shared responsibility model, where customers are simply, absolutely responsible for security of their data in the cloud, with the cloud providers being responsible only for cloud infrastructure, not the data stored in the cloud. So we're not really making this up, because the cloud providers participated in the development of the shared security model for cloud computing. And what you see on this slide are two screenshots from blogs published by AWS on the left and Microsoft Azure on the right. The AWS blog was published in 2014. The Azure blog was published in 2016. And you can see at the bottom of the slide, there is a link to a document that you can find by simply Googling shared responsibility Gartner. Gartner published a second or third version of their discussion on the shared responsibility model back in 2016. So the shared responsibility model is A, long established, and B, well adopted and established by the cloud providers themselves. Before I move on from the slide, I just want to call your attention to some of the visuals that are very obvious here. First, consider AWS. Whoever created that diagram depicted it correctly. It turns out that Amazon's view that customers are responsible for security in the cloud has a much larger amount of blue than the burnt orange that you see with AWS's responsibility for security of the cloud. And so what you discover when using AWS, which is largely an IaaS and PaaS provider, that customers have a lot of work to do to secure their data and their infrastructure. Turning to Azure on the right, this is a diagram that I really love. For example, the left blue column actually says on-prem. And you got to give Microsoft cred, because they are one of the leading providers of on-premises software solutions, let's not forget. And they do a good job of illustrating that if you're not consuming the cloud and your data is on-prem, well, you are responsible for everything. Another interesting aspect of Azure is that unlike AWS, Microsoft actually has a comprehensive SaaS offering, for example, in Office 365. But the main takeaway I want you to consider in the Azure diagram is the top row, where labeled data classification and accountability. Accountability is an interesting way of saying that you, the cloud customer, are accountable for the security of data, which means you're responsible for data security. So if you're responsible for cloud data security, you might go through a range of stages in addressing securing your data. The guy on the left thinks, let's just do nothing. I'm going to depend on the network infrastructure and the network infrastructure people to protect my data. This doesn't really work, evidenced clearly by the unbelievable number of breaches of data in the cloud. Then we consider, let's encrypt data so that we can say that we're compliant, for example, with the shared responsibility model or data protection mandates that say data must be encrypted. And native encryption in the cloud can be used to encrypt for compliance and for a certain amount of data protection. It is also possible, and this is discussed in Victor's video series, that it's possible to encrypt data even better for a high level of security by bringing one's own encryption. Now let's consider choices in data at rest encryption in the cloud. Cloud native encryption pluses are that it's really, really easy and it has very, very low direct costs. Encryption is typically free in the cloud, And only when you start managing your own keys really do you start incurring any meaningful costs. Some of the minuses of cloud native encryption include, for example, the cloud provider typically sources and holds the keys. Next, cloud native encryption is generally identical to full disk encryption, wherein it serves OS clear data. It serves to the operating system clear data. And in effect, because of the complexities of managing cloud native encryption, in particular across multiple clouds, cloud native encryption could have high indirect costs, such as the cost of data breaches, and so on and so forth. Bringing one's own encryption has a range of pluses, such as the ability to move your cloud from data from cloud to cloud without having to decrypt it. Typically, bring your own encryption solutions offer OS level access controls and a range of advanced capabilities, such as the ability to encrypt data inside of containers and encrypt data while it's being rekeyed. One of the pluses of bring your own encryption is it has relatively low indirect costs, but of course, its minuses are that bringing one's own encryption in various ways can seem very, very complex. Another thing to consider is that bringing your own encryption for platform as a service requires developer assistance. And another consequence of bringing one's own encryption is that typically, unlike cloud native encryption, you have to pay for it, creating medium rather than high direct costs. But we simply can't argue with the easy button. Cloud native encryption is extremely easy to use, and many, many customers actually use it. But if you use cloud native encryption, what about the keys? Well, the Cloud Security Alliance, which is a global organization dedicated to the creation and promulgation of best practices in cloud computing, publishes a document known as the Cloud Controls Matrix. The Cloud Controls Matrix is this titanic spreadsheet of cloud security controls organized by security disciplines. And anyone can download the Cloud Controls Matrix from the CSA's website. If we delve into the Cloud Controls Matrix, we discover a section titled Enterprise Key Management, and this pertains to the cloud. And in row 4 of Enterprise Key Management, we read that as a security best practice, encryption keys shall not be stored in the cloud, but instead maintained by the cloud consumer or a trusted key management provider. So an independent organization known as the Cloud Security Alliance is telling you straight out that one way or another, you should try not to store your keys in the cloud, but rather bring your own keys to the cloud. And from here, I'd like to give the presentation over to Victor to tell you about how you can bring your own keys to multiple clouds with convenience. Vic?
Thank you, Eric, and hello, everyone. So as we just listened to Eric, once we decide and have a requirement to bring our own keys, whether that's because we need to store our keys inside a single tenant key store that has its own independent audit path using a FIPS 140-2 level 3 validated HSM, or simply because we're looking to gain more control over the key generation, having a backup of keys, or a way to delete the data by deleting the key material on demand. Whatever the reason might be, the challenge that comes with bring your own key is that you're not responsible for the entire key management aspect of encrypting your data. When it comes to managing your keys, you have two models you can follow. And if Eric, you can jump to the next slide. The first model is the centralized manual way of managing your keys. What you see here is a circle is a depiction of the National Institute of Standards and Technologies, which outlines the encryption key lifecycle best practice recommendations. You can download the 3-part document by simply Googling NIST key management. And while NIST is not explicit about on-premises versus keys in the cloud, We can take these recommendations and apply them to both environments. The challenge that everyone faces with these models are reflected in the circles you can see. Yes, you can source keys in an HSM or even use an open source tool like OpenSSL to generate your key material, but everything in red is complicated, time consuming, and fraught upon with high error risk. And it gets more complicated when you move over to the cloud and even more when you go multi-cloud. So the second model is the one that I like to introduce. This is more the decentralized automated way of managing your keys. This is the model that everyone's looking to implement. And to help us automate the key lifecycle management, I'd like to introduce CipherTrust Cloud Key Manager to help us reduce the complexity and time spent on key management. CipherTrust Cloud Key Manager is a multi-cloud data at rest encryption key management solution that is focused on enhancing our security team efficiency when it comes to managing our own keys. It enables us to protect and centralize our key management across multiple cloud providers and the different cloud models from infrastructure as a service, platforms as a service, and software as a service. When we do decide to bring our own keys and manage our own keys, we should be able to meet the same encryption security standards and compliance needs that our native key management services are offering us. Luckily for us, CipherTrust Cloud Key Manager supports two of the leading key management solutions in the market with a track record of providing strong encryption keys and controls using FIPS certifications that are validated up to level 3. And it also meets our compliance needs. The two external key sources it supports with CipherTrust Cloud Key Manager is the CipherTrust Manager, which is a rebrand of the Gemalto Key Secure, and the Biometric Data Security Manager. We'll learn more about both of these appliances in another slide, but for now, let's look at the differences between the different products and SaaS services that CipherTrust does support. In this slide, we can see the different providers and cloud models that CipherTrust Cloud Manager supports. Under IaaS and PaaS, CipherTrust can bring and manage your keys inside of Azure, including the different regions of stacks, AWS KMS, and IBM Cloud using their Key Protect key management service, with Google Cloud KMS scheduled for release later this year. On the software as a service side of the house, we have CipherTrust supporting key management for Microsoft 365 and Salesforce using their Shield platform encryption. When we look at bringing our keys, one of the major challenges to your lifecycle management process is key rotation, as you're now having to manually rotate keys based on a predefined schedule or key expiration rule. With CipherTrust Cloud Key Manager, it allows us to automate the process of having to manually rotate the keys and delete archive versions of the key with very little effort. Depending on the cloud provider and KMS option you decide to use, the provider may or may not offer you the option to back up your own keys. With CCKM, we can automate the backup of our key material as an insurance policy in the event that the cloud provider decides to lose our key material. Now, it is true that for AWS KMS, if you delete the CMK, having a backup of the key material does you no good. However, as part of your monitoring and security controls, you can reduce the risk by monitoring and triggering an event whenever someone schedules to delete the CMK, or by removing the KMS schedule key deletion action from your key policy. The other benefit to CipherTrust Cloud Key Manager is that not only can you manage the keys you import, but you can also manage all native key types from a central location. This means that you can manage the keys that you bring and also manage the native keys that are supported by each of the native key management services. And the last thing that I want to point out is that with the agility and the speed of the cloud, with CipherTrust Cloud Key Manager, we can schedule an automated synchronization of our keys, which pulls and builds an inventory of our keys across the different multiple regions using a predefined schedule. You can schedule your synchronization every hour or 24 hours, depending on your security standards. And this way, you're able to track any new keys that might be created outside the CipherTrust Cloud Key Manager appliance. The real benefit to CipherTrust Cloud Key Manager is when you go multi-cloud and you're having to manage multiple accounts, subscriptions, or projects. As we learned earlier, we can use CipherTrust Cloud Key Manager to manage our keys across an ever-growing number of clouds and SaaS providers. Next slide, please. By using a solution like CipherTrust Cloud Key Manager, we're able to achieve strong encryption key security by addressing two key areas. The first is around addressing Cloud Security Alliance Cloud Control EKM04, which states keys should not be stored in the cloud, but maintained by the cloud consumer or trusted key management provider. And the second is around making sure that our external key sources are FIPS validated using 140-2 and can be validated up to a level 3. But we'll talk more about this on a different slide. When it comes to key visibility and auditing, you have CipherTrust Cloud Key Manager that can generate 5 reports out of the box. These reports include details such as key activity, service usage, key agent, and user action against this key. The way CipherTrust Cloud Key Manager is able to generate these reports is by pulling two sets of audit logs. The first are the logs associated with CCKM, which include detailed actions around the lifecycle management of the keys. And the second is by pulling logs from the cloud provider, which includes details about how the keys are being used.
I thought I would just throw one thing in here before we leave this slide.
Sure.
That is, CipherTrust Cloud Key Manager has a RESTful API into its activities such that you can you can control what it does, but you can also use CipherTrust Cloud Key Manager's APIs to create your own custom reports in the system. And one thing I'd like to say about the activity logs that is crucially important is that CCKM's activity logs can be directed via the syslog protocol to SIM systems so that you can integrate key operations seen across multiple clouds from CCKM into your SIM systems such that you could get very, very early warning of any potential misuse of encryption keys.
Yeah, that's a good point, Eric. I was going to mention that you could send your logs to a SIM or any other external log collector using syslog. But great point. In terms of deploying the solution, there are two components and two models we can choose from. Starting on the top left of the screen, we can deploy CCKM in both public cloud inside AWS, Azure, or IBM, or in private cloud using Azure Stack or VMware. In addition, we can deploy CipherTrust Cloud Key Manager in our on-prem data centers, giving us more control and security over our appliance. The other component to the solution is the external key source. As we learned earlier, CipherTrust Cloud Key Manager supports two different external key sources, both of which are FIPS 140-2 certified. We can choose from either a hardware or a virtual appliance. The hardware appliance are level 2 validated and can be upgraded to a level 3 by installing an additional HSM card inside the box. With the virtual appliance, we can achieve level 1 with an upgrade path to level 3 by using another external HSM such as a Luna HSM. And in doing so, we add another tier to our key hierarchy. Anything else you'd like to add to this, Eric? Or
no, thank you for covering this in great detail. I'm not sure if you said it, but one of the aspects of CipherTrust Cloud Key Manager is that where you can deploy it is sort of intrinsically interesting in that even if you operate CipherTrust Cloud Key Manager in the actual cloud that you're using, you still have control of your keys. And so you can deploy CipherTrust Cloud Key Manager, for example, from the Azure or Azure Stack marketplaces. And then you can instantiate your key source, for example, in those same marketplaces. Deploying your key manager and your key source in the cloud is not a conflict with the shared security model because you are in control of both the key source and the key manager, whether you run it on premises or actually in the cloud.
Yep, good point, Eric.
And we'll move on.
With AWS KMS, while AWS integrates with most of their native services, not all services allow you to bring your own keys. Here we have a list of all the services that do support bring your own key using a customer-owned CMK, also known as an external customer-managed CMK. And don't worry, these slides will be provided, so you don't have to take a screenshot or try to write these down. But a little pro tip that I like to give to our listeners is that when you're looking at all these services and you're looking to do server-side encryption, there's two services that I'd like you to focus on. The first one is S3 and the other one is EC2 using EBS for disk level encryption. And the reason why you should focus on these two services specifically is because all the other services focus on these two different models. With S3, the model of encryption is that it generates a data key and also an encrypted data key and uses that data key to encrypt your object. However, that data key is then discarded. When we look at EC2 and the way it does EBS disk level encryption, the data keys are not deleted, but instead stay persistence, allow you to do transparent encryption. So there's two different models of how AWS handles encryption, and usually all the services fall under these two models. So as you're looking to do server-side encryption inside of AWS, I would say focus on these two services first, and then the other ones will come later.
Thank you, Vic. That's awesome.
Same thing for Azure, right? So Azure, each of the key management services support a number of different customer master key types. In AWS, they call it external customer master managed key. And with Azure, they call it customer provided key, right, Eric? Something like that?
Yeah,
Yeah.
The terminology is a little dizzying.
Yeah, so out of all the services in Azure, the ones that do support bring your own key are listed here in the screen. And the same thing, I would focus on blob storage and also looking at Azure Disk when you start off doing server-side encryption, and then from there everything else will kind of fall in place.
And I think we're trying to illustrate for you on these two slides with these vast number of services is the richness of the cloud provider offerings in infrastructure as a service and platform as a service. And the complexity that goes along with that richness. But we will provide these slides to you, and our intent in showing these vast lists of services that use Key Vault and BYOK in Azure and AWS is to give you confidence in your bring your own key strategy, because you can know from these large lists of services that you can bring your own key to the cloud and utilize these services. We do not have a slide yet for IBM Cloud. We haven't had a chance to research all the services that hook up to IBM Key Protect, but we hope to have a slide like this for IBM Cloud Computing in the very, very near future.
Hey guys, this is Michael, and everybody on the call. If you don't know, this is Michael Farnham, CTO with Set Solutions. So we do have a question that may be good to answer now, since you're talking specifically about IBM. One of the questions that's coming up is, will Alibaba be supported?
Right. Alibaba is on our medium-term roadmap for delivery provisionally in early 2021.
Okay, thank you. And we've got a couple more questions. I'll let you guys work a little bit more, and then we'll answer some of these questions towards the end.
Yeah, we want to keep it as interactive as possible, but I think that Vic can wrap up here, and then we can go on to resources. Victor?
Yeah, we're almost getting to the end. So in this slide, it kind of gives a summary of the CipherTrust Cloud Key Manager 4 benefits that it offers us. The first is that it gives us a decentralized key management solution that we can deploy, in multiple cloud environments using FIPS validated standards based on different internal key management standards. By centralizing our key management, we're able to gather an inventory of all our keys for all key types across all regions, accounts, and even between cloud providers. The other benefit is that we gain IT efficiency. The way we do so is by automating the entire key lifecycle aspect, from creating, importing, rotating, backup, and even deleting the keys based on predefined security controls and policies. Now, whether you're looking to see how your keys are being used and managed, or need to respond to an incident that involves data exposure or exfiltration, you have a way to generate reports using detailed audit logs. And kind of going back to the Cloud Security Alliance Cloud Control EKM 04, which states keys should not be stored in the cloud, with CipherTrust Cloud Key Manager, we're able to achieve and meet our compliance needs using an external key source that is FIPS validated and can be hosted inside of our data centers.
Thanks. I think what we're going to do here is, because I'm the marketing guy and Victor is the technical guy, I want to talk about resources with, I want to talk about the resources. So first, I want you to go to YouTube and look for Ready, Set, Secure. Set Solutions is doing an absolutely amazing job of providing teaching tools for cloud security, and it's centered around Victor's cloud key management channel. So if you find Ready, Set, Secure on YouTube and just look for cloud key management, you'll see these 4 videos. I am beyond enthusiastic. I want to give you just an example of why I'm so enthusiastic. I have been marketing CipherTrust Cloud Key Manager for almost 3 years, And I learned new stuff from watching Vic's videos. So everybody can learn how key management in the cloud really, really works from these 4 videos. And the next thing is that bookmark the Set Solutions blog, because I'm not sure how soon it's coming out, but Victor is going to publish a blog on cloud key management around the topics that he covers in the videos in the very near future.
Correct. We have a blog coming up. It's a 2-part blog. So the first one's coming out this Thursday. So stay tuned for that one. And the following will be coming out in the following weeks.
And as you know, blogs are narratives, and they allow you to get information a lot more quickly than watching a video. So you can whet your appetite with the blogs and then go to the videos, or you can watch the videos and then go to the blog. So there's lots of paths to gaining knowledge here. And then, of course, this product has a web page, CipherTrust Cloud Key Manager website, and I'll make the link live in the PDF that you'll be able to download from the Set Solutions website. But basically, it's the typical product website, which has an overview of the product in somewhat more detail than we've covered today, and a range of resources that you can download and links to videos, including a video link that Set will provide to all attendees to a demonstration of CipherTrust Cloud Key Manager, so you can actually see it in action. So that really takes us to the end of our prepared content. And because this is a lunch and learn, I'd like to sort of make believe that we're all in a room together and handle the questions as they come in. So Mike?
So one question came up is AWS does not provide a backup key. Does CCKM do that?
And the answer to that question is AWS does not provide backup keys to the synthesized customer master keys that are created from the keys that are uploaded by CipherTrust Cloud Key Manager. So the great thing is that, yet again, I learned something from Victor today, and I'm going to paraphrase what Victor said, and I'm going to let him describe the answer in more detail. Because AWS does not provide backup keys for the synthesized keys, there is a potential risk of data loss if a customer master key is deleted in AWS. But I specifically heard Victor say that it's possible to use key control policies in AWS such that CMKs cannot be deleted. And I'll say one more thing about that. We've talked to a lot of customers about how they do both on-premises and cloud key management. And I learned very recently that we have no small number of customers that have IT sourced mandates that encryption keys will never be deleted. And that's an interesting story because you think never can accumulate a whole bunch of keys. Well, guess what? You know, there are not that many bytes, and there are a lot less data to retain forever than, for example, all the rest of your data. So Vic, can you describe in more detail how to absolutely protect keys from inadvertent deletion in AWS?
Sure. So there's 2 methods, right? So there's a couple of security guardrails that you want to add, to your key lifecycle management practice. And so when you look at your lifecycle, one of those is, how do you create keys? How do you rotate? How do you, import, delete, and all of that? So at the very end, it's the destruction option when it comes to managing your keys. Now, because the way AWS works and how it protects and tracks your keys, it uses a CMK, which is really just a container. And all the other services reference this container, the CMK, using either the key ID or the alias, right? And if the container is deleted, along with the key material, then there's no way to recovery. So you can reduce this risk by either, adding some monitorings and, responding to whenever someone tries to delete a CMK, or by updating your key policy by removing that KMS key, now I can't remember. I think it's scheduled key deletion. From the key policy. So that way, inadvertently, you don't have an accident of someone deleting the key.
I just want to call your attention. In the videos, Victor shows key policies. And so you can actually see how this is done in the video of adjusting key policies for specific needs. And I think, Vic, if you don't mind, Could you publish in your blog a little snippet of a key policy that prevents CMK deletion?
Sure, I can definitely do that.
That would be fantastic. Does
Yep.
that
And
answer that question?
I think so. The way we're doing Q&A, I mean, I guess they could answer directly on Q&A, but or on chat. But
Well, they can do a
if
follow-up.
if you're creating keys natively, you cannot back up those keys. You can only have a backup of the key if you import your keys, right? Because you're the owner of the key material. So hopefully that short little answer answers that.
So another question, can this help with preventing a subpoena for my data being delivered with my data in the clear?
Yeah. So this is a very interesting question. And it has to do with how the legal system works, largely in America, but it's also true in sort of any country that uses subpoenas to control search and seizure in private organizations. So the general idea of this question is that cloud providers can be served by a subpoena to provide data. And a cloud provider may feel legally obligated to respond to that subpoena. So the situation there is that all things being equal, subpoenas are typically served to both the organization that owns the data and the cloud provider where the data is actually stored. So the idea of data protection in the face of subpoena is that an organization might receive a subpoena and then use CipherTrust Cloud Key Manager to revoke the key as quickly as humanly possible before the cloud provider can actually act on the subpoena. This is a very complicated and challenging story because it depends on a lot of things that I just said and how the legal system actually works. Like, so for example, the persecuting organization might not share the subpoena with the owner of the data. They might only send the subpoena to the cloud provider. At that point, there's no mechanism for the organization to protect their data. So subpoena protection is a very, very large and complex legal topic. And the best way I can sum up my statements on subpoena protection before I hand the answer over to Vic is that Thales generally recommends that if you want to protect yourself from subpoenas served on cloud providers, that you bring your own encryption rather than bring your own key. Because if you bring your own encryption, the data is always encrypted and no one can get to the keys but you. And there's no revocation mechanism because the cloud provider has no mechanism to use the key because the keys used in bring your own encryption are not stored in the cloud provider's proprietary key vault as they are with BYOK. So it gets complicated. I hope that answers the question. And Vic, if you have any other remarks about subpoena, I'd love to hear them.
Yeah, I would just add that, if you're using the default encryption option, you may want to avoid using this option because you are acceptable to one of these blind subpoenas. And the reason is that when you use the default encryption option, the key that is used to encrypt your data is actually owned by the cloud provider. And because they own the data to the key and your data now, they can easily hand it over to whoever's requesting.
And then one thing I'd like to say here is that I just want to give props to my partner Set Solutions, because if you're curious about the choice between BYOE or BYOK, people like Victor are in a position to help you decide what to do about which data. And large organizations tend to use a lot of cloud properties, and you could choose to do BYOE in some cloud properties and BYOK in others.
Yeah, I think it also goes back to having a data classification, right? So for more your high sensitive critical data, those are the ones you want to bring your own encryption. And for some of the less classifications, such as data that might be public, maybe using some of the native keys is an accessible risk.
All right. So how does your key management solution work if we are using a third-party vendor to back up our Salesforce data through a different SaaS vendor for protecting our backup data? That's quite the scenario.
That is a tough question.
Maybe we can take that one offline.
Yeah,
and get with this person and talk that through.
Yeah, I don't have that is a really complicated situation that I think, Farnham, you're on the right track. If you guys could ask that customer whether they're willing to have a private meeting with the set and delve into that deeper.
All right, we can do that. And differences between Cipher Cloud Key Manager and Data Security Manager offerings.
I'll take that first and I'll let Vic fill in.
Yeah, go for it. I think that has to do with the two different external key sources, right? CipherTrust Manager versus data security.
Maybe I'll just go back to that slide that shows how these things are actually deployed. So the fundamental difference between CipherTrust Cloud Key Manager and, for example, either the Vormetric Data Security Manager or CipherTrust Cloud Key Manager is that CipherTrust Cloud Key Manager is essentially a key broker. It takes keys from key sources and puts them in cloud provider key vaults. The Data Security Manager is only a source of keys for BYOK. In contrast, CipherTrust Manager or the Data Security Manager, they are the key managers for bring your own encryption. So the key sources are sources of keys for BYOK and managers of keys for BYOE. And we don't illustrate BYOE on this slide, so it's hard to see what I'm talking about. But the main way to think about the question is to consider the difference between BYOK, which leverages cloud provider key vaults, and BYOE, which does not. Vic, do you have a better way of answering that question?
I think the question was more around what are the differences between both of these two external key sources, or which one should I go with if I decide to go with the solution.
Okay.
So you might know more about the differences, Eric. The one that I do know is that with the Vormetric Data Security Manager, it is more for bring your own encryption, but it offers you the live data transformation of being able to do automatic key rotation without having to have any downtime. So that's one of the pluses, and that's currently being, I guess there's a roadmap, Eric, that feature's kind of being migrated over to the CipherTrust Manager.
Sure, right. And there's no harm with being open with our customers at a lunch and learn about what's going on with these product lines. And I don't have a slide to illustrate this, but the reason why there are two key sources visible at the bottom there is that that is Thales, acquired Gemalto and the legacy SafeNet product line a little over a year ago. And the legacy SafeNet product line and the Vormetric product lines were almost identical. And they both have key managers at the center of their universe of bring your own encryption and bring your own key solutions. So what's going on here is that we offer both the legacy SafeNet CipherTrust Manager as a key source and the legacy Vormetric Data Security Manager as a key source. And those are both available for bring your own encryption. But again, no shame. The product integrations are what they are. Long term, the CipherTrust Manager will be the key management system for our long-term deployments. However, if you want to use the value-added features that are available with the Vormetric Data Security Manager and Vormetric Transparent Encryption, you would want to deploy Bring Your Own Encryption with the Data Security Manager and Vormetric Transparent Encryption if you wanted to bring your own encryption. There's no harm in deploying either of these products because we plan on maintaining them long-term, well beyond your amortization of buying these products. But I will say that the long-term direction is to attach Vormetric Transparent Encryption for Bring Your Own Encryption to CipherTrust Manager, which will be debuting later this quarter, actually. it got really complicated there, and I very much apologize for those complications. And to really answer that question and recommend what to do and when to do it, I think a private meeting with Set Solutions and Thales and you who asked the question might be the best choice.
All right. We can definitely reach out. That was Young. We can reach out to him. Anonymous attendee here is, well, actually they were answering the question on the Salesforce, so I think we're okay there. They said as long as the customer has Salesforce Shield, CCKM should be able to keep the keys. That was the other question, but we'll still definitely be reaching out on that one. I think we've answered all of them, guys. Any other questions from the audience in Q&A or in chat? Otherwise, I think we'll wrap it up.
And if everybody wants to see a demo of the product, jump over to our YouTube channel and look up the videos labeled "Bring Your Own Key." And in that video, we have a demo of the product itself that walks you through the lifecycle management process.
Perfect. Well, thank you everybody for attending. We really do appreciate it. Eric, Vic, thank you for presenting, and hope everybody enjoyed it. And as a wrap up, please be sure to answer the questionnaire that will be coming out, and you'll be entered into a drawing to win an Amazon gift card. Dan, sorry if I'm stealing your thunder. I know you're still here. But wrapping up for you. Anything you want to add, Dan?
I would just thank everybody for showing up today, and thank you for trusting in Set Solutions.
Thanks, everybody. We appreciate it. Have a good day.
Thank you.
Thanks a lot.
Thank you.